In this lesson, we're going to be looking at angle bisectors. Before we discuss angle bisectors, it's very important to first understand what the term congruent means, because we're going to be using it in several different contexts moving forward. Congruent just simply means that two things have the same measure. So if two segments are congruent, those two segments have the same measure or the same length. Two angles are congruent, they have the same angle measure. To bisect means to split into two congruent parts. So if you bisect something, you're going to split it right into you're going to split it in half into two congruent parts. And an angle bisector is a ray that splits an angle into two congruent angles. So in this example, we're told that ray EF bisects angle DEG. So since ray EF bisects that angle, we can determine that those two angles are congruent. And then now I can use the angle addition postulate to add those two congruent angles and set them equal to the angle that's formed by those two angles. So measure of angle DEF plus the measure of angle FEG equals the measure of the angle that those two form, which is angle DEG. We're told the measure of angle DEG is 66. All right, so I don't know what the measure of each one of those angles are, but I do know that they're congruent, so I can just plug in x for both of the angles. X plus x is 2x. Divide both sides by 2, and x equals 33. So both of those angles are 33 degree angles. In this example, we are told that ray EF also, in all the examples, I believe ray EF is going to bisect angle DEG. So the setup is going to be pretty much the same for all these examples. In this example, we're told the measure of angle FEG is 31, so I want to plug that in. Since FEG is 31 and FEG is congruent to DEF, I should have 31 plus 31 equals angle DEG. When I add those two together, I get 62 for the measure of angle DEG, which is, you can just rewrite that angle another way as GED. Again, same setup for this example. The sum of the two adjacent angles equals the bigger angle that's formed by their non-common sides. All right, and since EF bisects angle DEG, those two angles are congruent to each other, so I'm just going to set those two equal to each other. Solve for x by subtracting 2x from both sides. Subtract 5 from both sides, and then divide both sides by 2. X is going to equal 7, and we're told to find the measure of angle GEF. The expression for angle GEF is 4x plus 5, so I'm going to replace that x in that expression with 7. 4 times 7 is 28, plus 5 is 33. Same figure. We're given a measure of 50 for angle DEG, which is the big angle that's formed by adding the two adjacent angles. And we're told angle FEG is 3x plus 1. Again, since those two angles are congruent to each other, I should have 3x plus 1 plus 3x plus 1 equals the big angle DEG, which is 50. 3x and 3x is 6x, 1 and 1 is 2. Subtract 2 from both sides, and then divide both sides by 6, and x is going to equal 8. All right, lastly, in this example, we're told that ray BX bisects angle ABC, so we should start with a figure. All right, in this figure, ray BX is bisecting angle ABC. So I could set this problem up as angle ABX plus angle XBC equals angle ABC using the angle addition postulate. And since ray BX is bisecting angle ABC, angle ABX and CBX have the same measure. So I should have 4x plus 19 plus 4x plus 19 equals ABC, which is 12x plus 10. 4x and 4x is 8x.